We're going to go through the answers here for exit slip 3-5. Our I can statement is to be able to find quotients using that traditional US long division algorithm. All right, so we're going to have a few problems to look at dealing with division here. So the first one's a word problem. We know that raffle tickets cost $8 each, and the drama department needs to raise $1,260 to put on the school musical. So we need to know how many raffle tickets do they need to sell so that they can put on this musical. I'm making equal groups here. I know this is division because I'm making groups of 8. So I need to raise $1,260. So what am I starting with is $1,260, and I need to divide that into groups of 8 because every 8, okay, is a raffle ticket. Remember the cheat step kind is when it says how many raffle tickets do you need to sell? The raffle tickets, that part comes second. That's that $8 because every $8 makes a raffle ticket. So I need to make my quotient, or the answer to a division problem, as a decimal, because this one's going to come out a little bit as a decimal here. So if I show my work up here, $1,260 divided into groups of 8. Okay, let's think about, move it down here a little bit, 1,260 divided into groups of 8, because every group of 8 is a raffle ticket. All right, so 12, 8, again, well, let's review this. For traditional, it's does McDonald's sell cheeseburgers? Okay, we like to write that up there. It reminds us we divide, multiply, subtract, check, and bring down. All right, so we're going to cover up the 1. And if I have 1, can I get a group of 8? And we can't. Some people put an X there or a 0. Some of us just move over. Okay, if I have 12, can I make a group of 8? Yes, I can. I can only make 1. Remember, we got to stay nice and lined up here. Okay, so I just divided. Now I multiply. 8 times 1 is 8, and I keep it all lined up in this column here. After I multiply, I get 8. The S stands for subtract. I check and I bring down, and 12 minus 8 is 4. And now check. Is that less than 8? If it is, then I made a good guess. Because remember, if this was bigger than 8, I would have been able to guess higher up here, and you'd have to go back and erase and do that. Okay, so everything's good so far. After I check, I then bring down one thing at a time. So I'm going to bring down that 6. And I'm going to start all over again. All right, so now I got to divide again, but this time I have 46. How many groups of 8? So again, if I know my facts, 8 times what gets me close to 46 without going over? 8 times 5 is 40. 8 times 6 is 48. That's too big, so I know my guess is 5. Okay, I divide it, so I multiply. 8 times 5 is 40. Subtract, I get 6. Check, that's less than 8, so I'm good. Bring down my 6. 8 goes into 60 7 times. 8 times 7, I know that because 8 times 7 is 56. Subtract, I get 4. Now we cannot use remainders anymore, right guys? Okay, we're going to add and have to do some different things now. So we're going to add a decimal here. Because $1,260, if I add a 0 after it, does that change any value? It doesn't. So I can add that, and then I know a decimal goes here. I don't use a remainder anymore. We have to answer in decimals. So once I have that, I can bring it down and go again. And in this case, it's going to come out. 8 goes into 40. Divide again. It goes in 5 times. 8 times 5 is 40. And now I get no remainder, and I know I'm done. So I know it says they can sell, your quotient as a decimal is 157.5 tickets they must sell to make enough money, to make that $1,260. So how many raffle tickets? Well, if you sell 157, that's not enough. So you would have to sell 158. You'd have to add on a little bit more there. Now it tells me to check it. Again, if I would take, in this case, I'm going to not use the 157.5. I'm going to take 158 tickets. If you multiply these two things, 158 tickets at $8 a piece, you should come back to your quotient. We should be a little over since this was a decimal and I'd have enough money. So 158 times 8 for my check step. 8 times 8 is 64. Carry my 6. 46. Carry my 4. And then 8 plus 4. And if I sell 158 tickets, I'm going to make $1,264. So that makes sense. I'd have enough, $1,260. Remember, we sold a half more of a ticket, which would be $4. So it makes sense that I got $1,264. And I can check that my answer makes sense. And then at the raffle, these guys know how many tickets they need to sell in order to raise this much money, know what their goal is. Have to sell 158 tickets. So make sure you get this written. Again, I'll pause the video if we need to. All right. And then there's just a couple more division problems here, and we'll run through that Does McDonald's sell cheeseburgers? Again, trying to do it in that traditional way. Does McDonald's sell cheeseburgers? The easy way to remember it. Divide, multiply, subtract, check, bring down. I think I'm going to do this one first because it's single digit. All right. The light's kind of shining right on it, isn't it? So I'll move this one a little bit here, I think, off to the side. All right, let's try that. All right. 5,572 divided into groups of 4. And I know I can get a lot of groups of 4. So again, I'm going to cover everything up but the lead digit. If I have 5, can I get a group of 4? Yep, I can get 1. So multiply it now. 1 group of 4. 1 times 4 is 4. Keep it all lined up. Subtract. I get 1. Check. Is 1 less than 4? Yep, then I couldn't make another group of 4, so I'm good. Next step, bring down. One thing at a time. Stay nice and organized. So now I have 15. After I bring down, I start all over again. If I have 15, how many groups of 4? Again, I know my facts. 4 times 3 is 12, so I know I can get 3 because 4 times 3 is 12. If I did 4 times 4, that's 16. That's too big. So now I subtract. I get 3. Check. That's less than 4. It was a good guess. So now I bring down the 7. Again, I draw the arrows. Helps me stay lined up and remind me what I've already brought down. And divide again. I know 4 times 9 is 36, which is really close, so I know I'm going to guess 9 on my divide step. Multiply. 9 times 4 is 36. Subtract to get 1. And one more thing to bring down. And it looks like this one's going to work out. How many groups of 4 can I get out of 12? I can get 3, because 4 times 3 is 12. Subtract, I get nothing left. So this one came out as 1,393. Didn't need to add a decimal and a 0 and keep going. Okay, is what you do if we have decimals. Didn't need to there. Okay. This one now, a little tougher because I'm making groups of 71. I don't know my facts for 71. Okay, so let's start out with 8. Same process. If I have 8, can I get a group of 71? Nope, so I just move over. If I have 89, can I get a group of 71? And I can get 1, because I know 71 times 1 is 71. Easy guess there. Subtract, I get 18 left, which is less than 17. So it was a good guess. Bring down the 2. Start over. Now 71 twice, I know 70 twice. I'm thinking 70 times 2 is 140. You got to do some mental math in your head, and why we do mental math a lot of times on our warm-ups. 70 times 2 is 40. I'm kind of pretending this thing's 70 since it's so close. 70 times 3 is 210. That's too big. I know 70 times 3 is 210 because 7 times 3 is 21. Okay, times 10 is 2 times bigger. It's 210, or 10 times bigger. Okay, so in this case, I'm going to guess 2. So I've got 71 times 2. Some people like to go off to the side and write it. That's fine. 71 times 2. Some people can do it right here by just taking this times this and this times this. Either way works. I'll just do it down here quick. 2 times 1 is 2. 7 times 2 is 14. So 71 twice is 142. Subtract. I get 40, which I know it's less than 71, so I didn't have that much left. I know my group is right because it's less than 71, so I know I made a good guess. Bring down my 6. Now I've got a big one, 406, and I've got to decide how many groups of 70 I can get, of 71 I can get. So I'm just going to, again, do my facts using this kind of lead digit, this 7 or 70. I know 70 times 5 is 350, and that's getting close. 70 times 6, well, 7 times 6 is 42. 70 times 6 would be 420. That's too big, so I'm guessing it's going to be 5. So I need to take 71 times 5. Again, I can go do it off to the side. And I get 355. So I'm going to plug that in here. Subtract to see what I have left. And I get 51, which is less than 71, and it's a good guess. So last step here, I just need to bring down my 3. And I got to do it one more time. And in this case, I know 513 is bigger than 406, so I know my guess is going to be bigger than 5. Again, let's go back to our estimating. 7 times 6 was 42, or 70 times 6 would be 420. I'm guessing maybe 7, because 70 times 7 is 490. That's getting pretty close. So I'm going to try a 7. So 71 times 7 is 497. Perfect. That's pretty close. Subtract. Got to do some decomposing the units of higher value there. And I get 16 left. We talked about how you can put a decimal and a 0 and keep going like we had to on the top problem. But for here, we're just going to put remainder 16. We're really just working, can we do double-digit division here? And so these are a couple of examples here of how we can do traditional long division, single digits and double digit divisors.